Hello, my name is Patrick Coleman. I am a chemistry teacher at Euclid High School outside Cleveland, Ohio, and also an educational technology grad student at Boise State University. I'm going to do a short demonstration called a Whoosh Bottle demonstration for you. I do it at the beginning of every school year to kind of help clarify for students the idea that safety is important, but not only that, the idea that sometimes things that you can't directly observe, like in this case a gas that you can't see, could potentially cause an unsafe environment. So what I have here for materials are, first of all, just a good old-fashioned water cooler bottle. That was a Whoosh bottle. Graduated cylinder, matches, beaker tongs, and we're going to use some isopropyl alcohol. What I do is first measure out about 20 milliliters of isopropyl alcohol. There we go. And I'm going to pour it inside our bottle. Okay. Let it settle there for a moment. Okay, next I want to basically try and just twirl this around for a minute or two. I'm doing two things. One, I want to coat the inside of the bottle with a nice thin layer of isopropyl alcohol, aka rubbing alcohol essentially. Just a little bit more concentrated version of what you might buy at a local convenience store. Well, we can keep in mind that isopropyl alcohol evaporates pretty quickly. That's why it feels nice and cool to the touch, kind of like acetone does, nail polish remover. And the reason why is it evaporates quickly. And when things evaporate, they actually remove heat from the surroundings. So literally, when the alcohol is evaporating, say off the back of your hand, and you feel that cool sensation in the back of your hand, that's actually because the process of evaporation is essentially endothermic. Now, we're going to make use of that because by kind of thinning out this layer, we're speeding up the rate at which the isopropyl alcohol will evaporate. Okay? And isopropyl alcohol is a little bit, actually the vapor is actually a little bit denser than air, so it's just going to kind of settle, okay, in the Whoosh bottle. And you want to make sure you got most of it gone. You don't want too much left over in there. Okay. Then, making sure I have my goggles, my apron on, safety first, obviously. I'm going to go ahead and light a match. I'm going to dim the lights first. So when I do dim the lights, you may have a hard time seeing me with regard to the camera shot. We'll see. I don't know. But you'll definitely see once I light the match and hold it over the open mouth, you'll see a pretty quick but intense blue flame, and you'll certainly hear a loud whoosh. It's actually the sound that most folks find a little more alarming than anything else. Now, before I do that, I am going to dim the lights. Let me go ahead and do that. All right, be right back. Okay, here we go. I'm going to light the match. I'm going to hold the match over the opening. And we may or may not get the desired effect when I hold it over the opening. If we don't, I'm just going to let go and drop the match in there. At that point, we'll definitely get the desired effect. So without further ado, here we go. Just going to hold it. Boom. Voila. There we go. So, as you can see, safety is important. Oftentimes, something that you don't sense or see directly around you can cause major potential for problems and injury and all that stuff. So, in this case, this was a demonstration to hopefully clarify the idea that alcohol vapor is something to be very, very careful working with around any kind of flame. In fact, we obviously want to avoid working with alcohol vapor and a flame in any kind of proximity with one another. This is obviously very controlled, but in the lab, if we're not careful, we could have an uncontrolled version of that. So that is it. Thank you.